So do you know now what is a solid, what is a cross section, what is the, how to find the area of the cross section, how to find volumes by slicing, and what are the solids of revolutions, what is the disk method, the washer method, to find the volume of solids of revolutions. These are the objectives that you need to check, the learning outcomes that you need to check. Are you aware about them or not? Did you gain these skills or not? Let's check this together. Let's see, for example, what now let's just, as I said, let's just recall what is the volume. In general, the volume is just the area of the cross section. It could be with respect to x or with respect to y. It depends on where it is perpendicular to the x-axis or the y-axis. If your cross section is perpendicular to the x-axis, you integrate with respect to x. If it is perpendicular to the y-axis, you will integrate with respect to x. So just you need to find the formula for the area of the cross section. This is the most important part. Of course, plus the limits of integration. After that, just you will integrate the area of the cross section. If you remember, this is the example that we showed. For example, this is one of the examples that we solved about a solid with a circular base. For example, the cross section here is a triangle. It could be rectangle, it could be square, it could be semicircle, it could be whatever. So now your task will be to find the area of this triangle. You need to draw the base on the XY plane to find the relationship between the variables that you have, and then you know what is the area of the rectangle, of the triangle, how to find it. After finding the area, of course, just you will integrate it. We have done this in the previous classes. So this is when you have any cross section. What is good about the solids of revolutions, that the cross section will be determined. It will be, of course, a disk or a washer. So if you have a solid of revolution like this, if you rotate it about the x-axis, you will have a solid like this. The cross section is a circular disk, and in this case, the formula of the area is ready. It is just by r squared. R here is the radius of the disk. And for example, this is an example. You have a region rotated about the x-axis. You need just to find the radius here. What is the radius? Is the distance between the upper curve and the lower curve to the axis of rotation. What is good here? We have a disk. When we have, ya shabab, the axis of rotation here is one of the boundaries. Notice, ya shabab, the region here is bounded above by square root of x and bounded below by y equals 0, the x-axis. And this x-axis is the axis of rotation. So in this case, we will have a disk. The cross section will be a disk. Now you need to find the radius of this disk. And the radius of this disk will be just the upper curve, which is here square root of x, minus the axis of rotation, which is 0. This minus 0, square root of x minus 0 will give you r. It will be a function of x. You will integrate with respect to x, because here you will just draw a perpendicular line on the x-axis. After finding the area, this is, ya shabab, the radius. Square it, multiplied by, you have the area of the cross section. Integrate it from 0 to 1. X starts from 0 to 1. This is, of course, when the axis of rotation is vertical. So what you will do, you will draw a horizontal line perpendicular. It will be within the region, from the right curve to the left curve, within the region, perpendicular on the axis of rotation. And of course, you can see also here that the y-axis is one of the boundaries of the region. So because of that, the cross section will be a disk. And we will see that when we have a gap, when it is not a boundary, we will have a hole, and we will have a washer, not a disk. Now, because the y-axis or any line parallel to the y-axis, we have vertical. When the axis of rotation is, when the line of rotation is vertical, we will integrate with respect to y if we are using the disk method or the washer method. So just find the curve on the left, on the right, minus the x-axis here, the axis of rotation minus the x left. And you can see that clearly here you need to write your equation in terms of x. It is given in terms of y, you need to write it in terms of x, and this will be x right minus x left. This will give you, of course, r. Square it, multiplied by, and you are done. Just integrate. Clearly here from 0 to 8, y is running from 0 to 8. If you have any question, Shabab, you can just stop me anytime, because I'm just revising what we have done in the previous classes. Now, if the axis of rotation, this is the axis of rotation, if the axis of rotation is not one of the boundaries, so it is not boundary, it is not like here. In that case, your cross section will be a washer, not a disk, because of this space here between the axis of rotation and the region that you have. So in that case, you will have a washer, and you know when we have a washer, you have inner radius and outer radius because of the hole that we have here. So here, what will be the difference? The difference is that the area will not be just by r squared. In fact, it will be by multiplied by the outer radius square minus inner radius square. Just you need to find 2 radii here. Then integrate. This is an example, and please, Shabab, pay attention how to find, of course, the inner radius and the outer radius, and how to know that it is a washer or not. Look, this is the region that you have. It is bounded by y equals x and y equals x squared. Here they are. The intersection points are 0 and 1. Now look at your region. What is the axis of rotation? The x-axis. So what you will do, you will draw a line, this red line. You will draw a line. In fact, it is a rectangle, but I prefer to call it a line. It is a rectangle, and this rectangle will tell you that the thickness variable is delta x. So you will integrate with respect to x. But usually, as I said, it is better to have it as a line to make it much easier. But keep in mind that you will draw when you have a region like this. What you will do? You will draw a line within the region from the upper curve to the lower curve, perpendicular to the axis of rotation. This is step number 1. Next, what you will do, you will calculate the distance from the curve that is close to the axis of rotation, and you will find its length. Its length will be the inner radius, r small. And you know what is y here? Y here is x squared. And what is y here? Y here is 0. So it will be x squared minus 0, which is x squared. Here it is. Now, again, you will do the same for the upper curve minus the line of rotation. So what is y here? Y here is x minus what is y here? Y here is 0. So this will give you, of course, x. And this will be the outer radius, r capital. Now what you will do, you will square r capital and square r small. You will square them, and then you will multiply by and subtract. طبعا why here the cross section is a washer ya shabab, not a disk. If you look at your region, is the x-axis is a boundary for this region? Is not. There is a gap here. There is a gap, this space between the region and between the x-axis. So because of that, we will have a washer, not a disk. It is important to decide, is your cross-section is a disk or a washer? Let's we have repeated the same example, but this time we will rotate it about the y, or about the line y equals 2. So this is y equals 2. Again, you will do the same. You will look at your region. You will find the distance from the axis of rotation to the closest curve. Here it is the upper curve. From the upper to the axis of rotation, the distance from here to here will give you the inner radius. And the distance from the lower curve here to the axis of rotation will give you the outer radius. And you know how to find the distance in this case. Here the axis of rotation is above the region. So it will be 2 minus, what is y here? Y here is 2. What is y here? Y here is x. So it will be 2 minus x. This is the axis of rotation, the inner one, the inner radius, 2 minus x. The outer radius will be the distance from here to here. It is y equals 2 minus, what is y here? It is x squared. Both of them are functions of x. Square this multiplied by square multiplied by. Take by as a common factor, integrate. Expand, of course, to find this integral. So the main task, ya shabab, to ask yourself, my cross section, is it a washer or a disc? If it is a washer, what is the inner and what is the outer radius? And the idea of the outer and the inner radius is it should be so clear. Let's take one more example, and it will be, I think, the last one, about how to find also the volume when you have a washer. So we will repeat the same example, but this time with axis of rotation, or the line of rotation is x equals -1. So repeat the same example, the same region, the same region. A vertical line parallel to the y-axis. So who can help me, Shabab? What is the first thing that we should do? What we should do first? Shabab, can you hear me? Of course, the first thing that we should do is to sketch the region. So this is the region. This is 1. This is 1. This is 0. Okay, this is my region. What we will do next, yes, Shabab?
Find R capital and R small.
R capital and R small, the inner and the outer radius. How to do that?
The above.
You are right, but how to do that?
The above curve minus the lower one.
Left.
How to find that also? Again, the same question, I will repeat it. What should we do?
Okay.
Always, Shabab,
The
keep this in
curve.
mind. Yes.
Okay,
No.
the curve
We
under
should
the.
determine, first of all, we should determine where is the axis of rotation. This is the axis of rotation. So this is x equals -1. This is the axis of rotation. Good. Next. What we'll do next, ya Shabab? What we should do next?
Find R capital and R small.
Yes, your colleague said that. The question is how? What I should do to find R capital and R small, the inner and the outer radius.
Right and minus left.
The idea, Shabab, I said it several times. Look at this line here. Always, it is important. Look at the previous examples. Always we draw a line. The line here is, if you look at the red line here, this one. The red line here is here vertical. It is perpendicular to the axis of rotation. This is the axis of rotation. Now, where is the axis of rotation? This is the axis of rotation. So what we will do, we will draw a line. We will draw a line within the region from the right to the left, perpendicular to the axis of rotation. If the axis of rotation is horizontal like this, I will draw this line like this, perpendicular to the axis of rotation. So this is very important. Draw a line segment or a typical rectangle, if you want to think about it like a rectangle. Draw a typical rectangle perpendicular to the axis of rotation, if you want to use the disk method or the washer method. Is that clear? Now you can find the R small and R capital. You can find the inner and the outer radius. It will be so easy. So let's start with the inner. So the inner will be just the distance from the cross section, from the line of rotation to the closest one, to the closest curve here, at the same place, Taman, you here. So ask yourself, what is x here? Because of course this is y, Shabab. This is a horizontal line. So y is fixed. The change will be on x. So you will have here a curve to the right and a curve to the left. What is x on the right? You have y equal x squared. So x is what? X is the square root of y, because x is here. This is the second step, is the curves in terms of x and y. Here we will have, of course, y. Okay, now the distance from here to here will give you r small. This is r small. And the distance from here to here, this one, let me use another color. Then the distance from this part from here to here will give you r capital, give you the outer. Now, what we will do, ya shabab? So from here to here, let's start with r capital. R capital, it will be a function of y, because here we will integrate with respect to y. The axis of rotation is vertical. So it will be x right, which is the far one here, square root of y, minus what? What is x here? X here is -1. So it will be minus 1, it will be +1. This is the outer radius. The inner radius, which is the distance from here to here, x here is y. X here is y minus, what is x here? It is -1. So it is minus -1, it will be +1. And I did this for you here, by the way, with colors also. So this is the outer and this is the inner. So this is the idea, Shabab. It is very important. This is the main step. Khalas. If you have them, just you will integrate. Now it is clear. You will integrate with respect to y. The horizontal, the cross section here is perpendicular to the y-axis. So you will integrate for y. Y start from 0 up to where? Up to 1. From 0 to 1. You will integrate by times r squared, r of y all squared, minus r of y small, the inner all squared. So it will be by outside from 0 to 1. What is this squared? This one, bring it here and then square it. Minus this one, y plus 1 all squared, and then integrate with respect to y. So easy. So this is the main task, is okay, let me clarify this in general. Let's say that we have a region, this region. This is my region, for example, just any region like this. Okay. Ya Shabab, mute yourself, please. The session is recorded. So let's say this is a line here, and we have the axis of rotation is here. X equals L. This is the axis of rotation. Now here, this is of course the x right here, it is f of y. Let's say this is also here, x equals g of y. So now what you will do, you will draw a line. Let me draw it with another color. So you will draw a line from here to here, which will be perpendicular to the axis of rotation. Then this is, as I said, this is x equals g of y. Now, what will be the inner and the outer in this case, ya Shabab? What will be the outer radius and the inner radius? Are they going to be a functions of x or functions of y? Now, the inner radius will be the distance from here to here. And remember that here x is L. So this is r. And from here to here, it will be what? R capital. So both of them will be perpendicular on the y-axis, so they are functions of y. And you will integrate with respect to y. Now, what it will be here, Shabab? What will be the smaller one? The inner radius. The inner radius will be what? Who can tell me? Guys.
Fy.
It will be this minus this. What is x here? X here is g of y. Minus what is x here? It is L. Now, ya Shabab, who can tell me what is R capital? What is the outer? Yalla. What is the outer? Will be what?
F of y minus L.
F of y minus L. Okay. We don't have time to let you think like this. You take so time, long time. Let me draw. What about if the axis of rotation is here? If the axis of rotation is here, x equals L is on the right. What will be in this case R of y, and what will be R of y? What will be the inner and the outer radius? Who can tell me, Shabab? Now it will be from here to here. Then it will be the another one from here to here. This will be R small and this R capital. What they will be? What is R small? Let's start with R small, Shabab. What it will be R small?
y minus L.
L
F of
minus
y?
f of
L
y.
minus of y.
L, ya Shabab. L minus f of y. Be careful. It is on the right, so it is bigger. What is on the right is bigger. If you said f of y minus L, it will be negative. The length is not negative, impossible. It is a radius. Be careful. So now the next one will be L minus g of y. I wish this is clear. And the same concept can be applied when you have a region that is like this, for example, that is bounded by a curve. Here, let's say this is y equals f of x, and here you have y equals g of x. You have upper and lower curves. Now, if your axis of rotation is here, this is the axis of rotation. Let's say it will be what? Y equals L. Or if it is above, let's say this case. Now, in this case, the distance from here to here, it is R small, and the distance from here to here, it is R capital. In this case, R of x, it will be a function of x. It will be just what? G of x minus L. And R, the outer radius, will be f of x minus L. If this axis of rotation is above, let me do it here. If it is above the region, what you will have in this case? If this is the situation, you have, this is your graph, this is your y equals f of x, and this is y equals g of x, and this is the boundaries of the region, and your axis of rotation. Oh, I need much more space here. So let me draw the axis of rotation here. This is the rotation, which is y equals L. And this is my region, this is my region, this is the boundaries from the right and the left. This is y equals f of x, and this is y equals g of x. Now, what we will have, what will be the outer and the inner radii? The distance from here to here will be r, and from here to here, it will be r capital. Notice, ya Shabab, we have a washer here. Why we have a washer? Because there is the axis of rotation is not a boundary of the region. So it is not a boundary. In this case, we will have a washer. If it is a boundary, we will have, of course, a disk, because if there is a space here. Now, in this case, R of x will be L minus f of x. Is that right? Because it is above the region. The outer will be L minus g of x. I generalize this for you. I think now you must be able to figure out how to find the inner and the outer radius. Okay? Any question, Shabab? Let me now, the solution now, after having this, Shabab, it is so easy. After having the inner and the outer radius, you will square the outer, multiply by pi. Square the inner, multiply by pi. Take pi as a common factor, square, continue, and then integrate. Integrate here, it is clearly, you will integrate from 0 to y, because y values are running from 0 to 1. For more, ya Shabab, if you want more, I think we have like 7 examples and 3 or more solved exercises. For more, if you want more advanced ideas, you can see example number 8 and example number 9 in your textbook. This is a solved exercise. I will skip, ya Shabab, these 2 exercises. It is clear here how to find the inner radius, the outer radius. And from where to integrate. You need to equate them. Both this one equals to this one and solve. I think I did this for you here. Yes, the limits, how to find the limits of integration. And then integrate, you have a washer here. The cross section will be a washer. Similar one, but here the line of rotation is vertical. And you have the summary, Zubda Shabab. So, you know, in general, the volume is the integral of the cross section. It could be with respect to x or with respect to y. Okay. Now, if the cross section, if the solid is a solid of revolution, it comes from rotating a region. Then, if the line of rotation is the x-axis or any line parallel to the x-axis, if it is horizontal, this is the axis of rotation. Then the volume will be an integral with respect to x. If it is a vertical line, if the axis of rotation or the line of rotation is the y-axis or any line parallel to the y-axis, it is a vertical line. then you will integrate with respect to y. And this must be clear, Shabab, for all of you. The question is, what is a of x? What is a of y? It depends. If your cross section is a disk, it will be just pi multiplied by the square of the radius. If it is a washer, طبعا dot here, by dot يا شباب, here I mean x or y. It should be a of x, it could be a of x or a of y. Okay, now if your cross section is a washer, just it will be pi multiplied by the outer radius square minus the inner radius square. Is that clear? Let's practice if it is clear. يلا يا شباب, solve this one please. Solve this easy all the exam question in 2 minutes, and I will launch polling for you. No calculations here, يا شباب. Just evaluate or express the volume of the solid as an integral. So you don't need to find the integral. So I think 2 minutes are more than enough. The volume of the solid obtained by rotating the region enclosed by this curve. This is a parabola, and y, it is also another parabola about the line y equals 1. So because, ya shabab, here the axis of rotation is a vertical line, and we are going to use the washer or the disk method, the integration will be with respect to x. But don't worry about that. All the answers here are with respect to x. But even if you don't have choices, for sure this integral will be with respect to x, because here the axis of rotation is a vertical, and we will draw the cross section to be perpendicular to this. So we will have the thickness variable to be delta y, delta x, sorry. We are talking about horizontally here. It is horizontal line here. This is a horizontal line, y equals -1. This is the axis of rotation. So the cross section will be perpendicular to this, and the thickness variable will be delta x if you draw a typical rectangle. Clearly, we will integrate with respect to x. Take a shabab pen and paper and start solve. It is important to revise how to sketch parabolas. The graphing techniques, ya shabab, how to shift them up, down, and right and left, and so on. Good, we have like 6 students start answering this question. What you will do first, ya shabab, you will sketch the graphs. You should sketch the region. So this is step number 1. You should do this. I think we need the x-axis to be a little bit down. This is x squared plus 2. So it is x squared but shifted up. So it is not difficult. This is x squared, y equal x squared plus 2. What is the another curve? Y equals 10 minus x squared. You know how to sketch negative x squared. Shift it up. You will add 10. So it is like this, then you will shift it up. So it will be here. But it will open what, ya shabab? Down. So it will be something like this. This is y equals 10 minus x squared. This is the axis of, this is the x-axis. This is the axis of rotation. Let's say this is the axis of rotation. This is y equals -1. This is the axis of rotation. So we will rotate which region? You need to decide where is your region. This is the region that we will, this is the region bounded by or enclosed. Enclosed, it means that is closed. It must be closed by these 2 curves or these 2 parabolas. Okay? Is it clear? I give you the hint. Let's see how many students. MashaAllah. We have 22 students answered so far. طبعا if you did this two steps sketching the region in the right way, it will be very easy for you. Let me give you the second hint. The second hint is to draw, because the axis of rotation or the line of rotation is a horizontal line, we will draw a line that is perpendicular to it. The typical rectangle, we will draw it this way, perpendicular to the axis of rotation. This is my typical rectangle, and this will give me the thickness variable is delta x. So I'm going to integrate with respect to x because of that. Okay, so this is the second hint. I wish that is clear now. Let me see and finish, and I will end the polling, ya shabab. So let's see the answers and I'll share it with you. 7 students with A, 13 with B, 11 with C, and 1 with E. What do you think, ya shabab? What is the right answer?
B.
The right answer
B.
is B. We will see why it is B. Okay, now the volume will be the integral from where to where. We need to know, ya shabab, from where to where. So it will be from, we will integrate with respect to x. So it will be from here. Look at the region start here and up to where? Up to here. So my integral will be from this point to this point. The question is, what are these 2 points? What is the intersection point? You have y. So if y at them, it will be x squared plus 2 equals to 10 minus x squared. This will be 2x squared equals to 8, x squared equals to 4, x equals to positive or negative 2. So this is 2, this is negative 2. So we will integrate from negative 2 to 2. Okay. Unfortunately, there is no one in the choices with this option, but let's see. Now what we will do next, we will decide about, it will be by minus the outer radius with respect to x, of course, minus the inner radius, dx. The question is, what is the outer radius and what is the inner radius? Now, ya shabab, I will find, I will use, let me use this color. The distance from here to here, from here to the axis of rotation, from here to here, to the axis of rotation, this will be r small. So what is it? What will be r of x? It is, what is x, what is y here? It is x squared plus 2 minus 1. So it will be plus 1. So it will be x squared plus 3. Is that right?
Yes.
Now let's find the outer radius. The outer radius will be the distance from here up to here, from the upper curve to the distance until the axis of rotation. So what it will be, r capital. R of x, it will be, the upper curve is 10 minus x squared minus, what is here is minus 1, it will be plus 1. So we will have 11 minus x squared. Now let's go back to my integral. So now I will just square here 11 minus x squared all squared minus x squared plus 3 all squared, all of them integrated with respect to x. Now you can see clearly, if you look, here it is. But why here it is from negative 2 to 2 and here it is from 0 to 2, and also here there is 2 by. If you notice, Shabab, this integrand here, this one here is even. Because of that, we can use the symmetry of the region. So we have from negative 2 to 2, it will be from 0 to 2, but we will double it. So it will be by multiplied by 2. And of course, you have here the same expression. You need, of course, to expand it if you want to integrate. It is not difficult. And that's it. This is all what we have for today, Shabab. If you have any question, you can see me during the office hours. And we are done with 6.2. Tomorrow, inshallah, we will start section 6.